On the back side, we are still talking logarithmic functions. One of the things we're doing right here is just being able to look at an equation and talk about our transformations. Now, I don't think we necessarily have any that we graph and then, move, okay? We stick with more of the basic graphs. But just being able to look at an equation and know what it is. This chart's familiar, right? If you're struggling to remember those, we had it first semester several times. Topic 1. Okay, this was our Unit 1 paper, so you can always pull that out or get another one if you need it. But it's in your notes here. I'm not going to read through that. We've been through it a bunch of times. So as you look at these transformations, the questions are, how do the asymptote and x-intercept of the given function compare to those of the parent function? So when we talk about the parent function being either log of x or ln of x, natural log of x, okay? It could be the base, it could be any base, but the parent function is that log of x function. What do these other pieces do? So let's start off talking about what transformation do we see, and then after we talk about the transformation, we'll talk about, okay, is my asymptote going to change? Is my x-intercept going to change? So A, g of x equals log base 2 of x plus 3. I want to talk about just what's this graph going to do. Using our chart, log of base 2 of x plus 3. What are you seeing being done to this log graph? What do you think, Toph?
Translated left 3.
Left 3, because what do we see? We see a plus 3 in the parentheses. Here you go, folks. Right here. A plus 3 in the parentheses. I always say left to right opposite the sign. So that is left. So I'm going to write here that the graph translates left 3 units. And that's just so we can get down what's actually going on there. That base 2, realize that base 2 is just part of what our parent function is, okay? So that graph is that log base 2 of x is going to move 3 left. Now, okay, here's what I need you to visualize. What's going on with the asymptote and the x-intercept? And I don't know if it'd be helpful or not, but do you remember what the log graph looks like from yesterday? Look to the front side of your notes if you need to. But the basic log graph was what? Runs along the y-axis. And it does something like that, right? And so we want to know, does our asymptote, which our asymptote is currently the y-axis, and does that x-intercept change? So what do you think? If we take this graph and move it 3 left, are those two pieces going to change? They are going to change, aren't they? What are they going to do? They're both going to move left 3, okay? Not all transformations are going to change them, and you'll see that as we talk about some of these others. But the asymptote and the x-intercept are going to translate left 3 units. So, asymptote and x-intercept will translate left 3 units. If I'm recalling homework correctly, like a question like this is like a 3-part question, okay? The first one you're picking, okay, what is the transformation? The next questions is, okay, what does the asymptote do? And then the other question is, what does the x-intercept do? Okay, if I'm recalling correctly. Okay, let's think about B. K of x equals natural log of x plus 4. Think general with me. What does in general this graph do?
Left 4.
Okay, so left 4 up 4. I agree it's got to be one of those because there is a plus 4. What tells us? if it's left or right, that 4 would have to be, there would be your left 4. It would have to be x plus 4 in parentheses. Since it's not, what we assume is that it's just the x in parentheses, if there's no parentheses. And so that plus 4 is going to take us up 4. So I'm going to start off the same way I did last time. I'm going to say that the graph translates up 4 units. And then we have to talk about what changes, what doesn't. Asymptote and x-intercept. If I take this graph and I move it up 4, does it change? Okay. And do they have to have the same answer here? Okay. So if I'm taking this graph, my curvy graph here, and I move it up, does my asymptote change? No. That asymptote is still staying on that same vertical line. So asymptote does not change. Now, if I take this graph and I move it up 4, does this x-intercept change? Yeah. My graph will still cross the x-axis, yes? But as I move this piece up, and it's up here somewhere, my graph is going to cross the x-axis over here somewhere. Okay, closer to the y-axis. So I'm going to say, let's see, what did we say first? We first said asymptote does not change. And if I recall, I just have that the x-intercept does change. We don't have to find a new intercept. You know, we can say that it would change and be smaller, but the x-intercept does change is all I have written down. Okay, so realize they won't always do the same thing. Okay, and see when you're ready. Okay, so we have h of x equals 5 natural log of x. I'm not sure I agree with a reflect, because if there's a reflect, what do I have to see? A negative. Okay, we do have a number out front. Where's a number out front? That's these a values out front. And that means it's either vertical stretch or compression. 5 we know is bigger than 1, and so this is a vertical stretch by a factor of 5. So graph is vertically stretched by a factor of 5. Okay, so think about what a vertical stretch does to the graph. And we need to ask ourselves, is that going to change the asymptote and the x-intercept? So let's talk asymptote. Is it going to change my asymptote? No. Because remember, vertical stretch will just mean taking your y values and multiplying them by 5, right? So that means it's going to take, like this graph up here is now going to, you know, go more up there. Okay, that's what the vertical stretch is going to do. So asymptote's not going to change. What about the x-intercept? It does not change, does it? Because right now how I have this x-intercept, and this is just a basic one, in my brain it's at 1, 0. If you take that y value and multiply by 5, well 5 times 0 is still 0. So here's an example where neither change. Okay, asymptote and x-intercept do not change. Whatever you want. say yeah. I'm trying to be official. Short would have been neither change. I get it. I'm with you. As I said, Savas, I believe it's like a multiple choice type answer. So, okay, you got the idea, yes? This chart, it keeps coming back at us, okay? You should be very familiar with it. Whether it's memorized in that brain or not, you're familiar with it, right? So it keeps coming back. Always feel free to pull it out if you need it. Okay, bottom set. We are going to talk about inverses. And we talked about inverses a little bit yesterday. So we've talked about them previous this year. Recall, to find inverse functions. This is a piece we talked about. In order to find inverse functions, I got the fancy word there, interchange x and y. Basically, you just switch x and y, right? And then general rule of thumb, if you're trying to find that inverse function, we did this on last unit, you then solve for y. Okay? Now, in this unit, this may require, in order to solve for y, we may have to go out of log form, into log form, depends on the situation. Okay? So, let's practice finding some inverses. Okay? F of x equals 10 to the x plus 1. Well, first of all, I'm going to ask, what's f of x? F of x is another name for y. So just as your friendly reminder there, f of x is another name for y. How do I find the inverse? Switch x and y. So instead of y equals, I'm going to say x equals 10 to the y plus 1. Okay? So what we did right there is we switched x and y. Okay? What's my next job? Solve for y, yes? Where is y? Y is currently in the exponent. But my goal, when I get to the end, my goal is to say y equals. Like, that's my goal. Huh?
We're in a predicament.
We are in a predicament. Now, the hint up here was this step may require switching between exponential and logarithmic form. What's going to get us out of this predicament?
Log.
3 words.
Right.
Left, right, middle. Left, right, middle sound familiar, folks? Now, some of you aren't going to like it currently in this form because my left is on the right, my right is on the left, and so I would always, if you have any question at all, put your power on the left. When we say left, right, middle, that means that's left is either the log or the exponent. Okay, those are on the left. So now, if I do a left, right, middle here, then the left is 10. So the base of the exponent now becomes the base of my what? The base of my log. So it's going to be log base 10. So the 10 stays on the left. It just base of the exponent becomes base of the log. That's left. Right means this is going to be log of x equals the middle, which is the y plus 1. Okay, so that right there was doing a left, right, middle. How do I solve for y? It's y plus 1. We're going to subtract 1. And when we solve that, what are we going to have?
Log base 9. X equals 1.
No. Okay. Log base 10 of x and minus 1. Okay. I can't add or subtract from a log. It's just not an option. So right there we made it y equals. You could possibly leave your answer like that. There's also the possibility, do you remember inverse function notation? Since this started as f of x, inverse function notation is f negative 1 of x. And you could also possibly write it like that. Okay, where you're just taking the y and replacing it with f inverse x. That's just stating that this is the inverse function. Okay? Questions? From here, it's just a matter of, okay, what tricks do we have to use on each problem? Okay, so if we look at B, g of x equals log base 7 of x plus 5. I know g of x is the same as saying y. Okay. Take x and y and flip. What's this become? Okay. Y equals become x equals. Log base 7 of x plus 5 becomes log base 7 of y plus 5. My job is to solve for y. Where is my y? In the parentheses inside the log. Now we're going to go the other way. Okay, so we're going to left, right, middle again, but this time we're going out of log form to exponential form. Now, if you, I don't know, in order to do left, right, middle, your log base 7 is the left, yes? It's on my right side. So if you feel the need, rewrite this as log base 7 of y plus 5 equals x in order to do your left, right, middle. So, the left of, what's my left? The base of 7. So the base of the log now becomes the base of the exponent. 7 to what power? Left 7 raised to the right x equals the middle y plus 5. So again, there goes our left, right, middle. So we start off switching x and y, and then here we did a left, right, middle. And how do we solve for y? Okay, if it's y plus 5, I'm going to subtract 5. And we're going to have y equals what? Okay, 7 to the x minus 5. Also could be written as f inverse of x equals 7 to the x minus 5. Why am I not subtracting 7 and 5? 7 has the x on it, right? Okay, you've seen one of each. You got the gist. Let's try C. F of x equals 3 to the x plus 2. F of x is another name for y. We're trying to find the inverse. How do I find the inverse? Y becomes you guys are all just working ahead, I hope. Okay, y becomes x, x becomes y, right? So instead of y equals, it's x equals. Instead of 3 to the x plus 2, it's 3 to the y plus 2. Shocker, where's the y? In that exponent again, isn't it? So how do we get y out of the exponent? We go back to log form. Now, in order to go back to log form, if you've got it figured out from this view, awesome. If not, by all means, let's flip this before I do it. So anytime I am going to do the left, right, middle, I'm going to put that base on the left, whether it's the log base or exponent base. So, okay, left, right, middle. the base 3 of the exponent now becomes the base of the log. So 3 on the left, x on the right, so log base 3 of x is going to be equal to the y plus 2 from the middle. Keep the 3 as a base, flip your y plus 2 and x. How do I solve for y? Okay, subtract 2. And again, we did a left, right, middle. What do we get as an answer? Okay. Log base 3 of x minus 2. Are you looking at the previous problem?
No, you just said that a lot.
Oh. Okay, so f inverse of x equals log base 3 of x minus 2. And again, Savish, you guys know, you're not going to have to type in the y equals or the f inverse of x equals. Okay? It's just a matter of knowing their equivalent. That's what I was talking about. Okay, one last one. Now you guys get some more time. G of x equals log base 7 of x minus 2. Where are you starting? Okay. G of x is y. And then I'm going to switch x and y. So instead of y equals, x equals. Instead of log base 7 of x, it's going to be log base 7 of y minus 2. Okay. Thoughts on this one? Well, I'm not exactly convinced I can think left, right, middle yet. Because here's the deal. Okay. Normally, what have I been doing? I've been taking the log before we do left, right, middle. And I've been putting this over here, right? So log base 7 of y minus 2 equals x. Well, here's the deal. The left is the base, right? The right is whatever's over here on this side of the equal sign. The middle is supposed to be whatever is inside the log. What's inside the log here? The y. Is that minus 2 a part of the log? No, it's not a part of the log. And here's the deal. If it was a part of the log, there would be parentheses there. Were there parentheses there? No. So, like I mentioned earlier, that means what you would assume is that it's log base 7 of x, and the minus 2 is extra. So before you can do a left, right, middle, this log has to be by itself. How are we going to get it by itself? We're going to add 2. So then we have log base 7 of y equals x plus 2. Okay, so slight catch there you have to watch out for. Now to get it out of log form and get access to the y, now I'm ready to talk left, right, middle. So how's this going to read? The left of 7 raised to the x plus 2 is equal to the middle of y. Left 7 raised to the right x plus 2 equals the middle y. And what just happened on this one? We're done, aren't we? Y equals 7 to the x plus 2, or f inverse of x equals 7 to the x plus 2. Okay. You have a little bit of time. Use it to be working on 6.4. Okay. Our plan for next week is 6.5 and 6.6. And then that puts us into a test the following week. Okay, as it stands right now, tentative, if everything stays on track, we're going to be testing March 6th, and then March 7th, we won't really have a class because my juniors will be at SAT. So,
We don't take any SATs, you do. Sophomores?